the imports command. Why do we use imports? Okay, all right. And when we're working with objects, all right, and when we're working with Java objects, the predefined Java objects, then that's usually something. Do I have you guys? Okay, huh? Yes, okay. The Java predefined objects are almost, especially if we're using something special, will almost always have to be imported. And you saw this the last time in the scanner class, when we were doing the scanner class, and we had to import the scanner class. So we will be importing a wide variety of classes as we look at using predefined classes in Java. And what you'll see is that the predefined classes in Java allow you to do a lot of things. And Java is not what we call a rapid development environment, or RDE. In other words, you can't just throw a form up there, slap a couple labels on, a couple buttons, and be done in 10 minutes, like you can with VB. Java was originally designed as a text-only language. I mean, it was done at the dot prompt. It was done with a text editor. So when you wanted to display forms and things, there's a whole lot more to it than there is with a language like VB. So those classes and things must be added to your programs. Now, we're not going to go right now as far as adding buttons and doing stuff like that, because that requires that we create our own listeners and all kinds of other things. But what we are going to do is take a look at how could we put output so that it shows up in a window instead of just down there at the bottom of your screen. All right, some things like that. But those classes all have to be imported. So, and if you had to write those classes as opposed to importing them, it would take forever. That's one of the reasons why we start off with objects and using predefined objects, so that you understand how beneficial it is to have your objects defined for you early on. You know, so then when you create reusable objects of your own, there's a purpose behind it. Okay, so right now, today, we're going to talk about the first 4 topics. Okay, because those deal with the basic classes that we will use the most. Right? And then we'll get on to some other things. So when we look at this, you created an object. When you did, oh, that was the wrong thing to do. Hit the escape button. When you did scanner scanner scan equals new scanner system in. Thank you. Okay, that created a new instance of the scanner class called scan. Okay, and we did that last time. Now, the string object is not created using a new variable because it's used so much. You have to understand, when you talk about how a computer uses or stores strings, it stores them using an ASCII character code. So each letter has its own memory space. All right? So if we were to just take, for example, title, T-I-T-L-E, where you're not going to see T-I-T-L-E, what you're going to see are the ASCII character codes for those letters, all right? So because of that, and a primitive variable, if I have something defined as an integer, it is simply stored in its own space, 18, all right? It's stored in its own memory space. So strings have to be handled differently. They can't be handled the same as primitive variables. Originally, in Fortran, strings were in an array, and each element, each letter, was an array element. And so then to get a string out, you had to loop through the elements. Well, it takes a really long time, but not only that, it was kind of, what they figured out was it was kind of fruitless because you were doing the same thing over and over and over and over again to get the stuff out. Okay, so we have a object that we create, a string object, okay? Now, because these are in, and I'm just going to use example addresses, 101, 102, 103, 104, and 105. How do I know how to reference it? Because I'm in 5 different addresses, right? Okay, so if I accessed memory position 101, it would simply get me the T. Does that make sense to everybody? Okay, so instead, what we do is we create what's called a reference variable, all right? And that reference variable holds the actual address of an object. So instead of exactly storing it like this, you have a workspace set aside within your memory. And in there, I can store the word title, okay? Now, it has one address associated with it, probably the first letter, but it has one address associated with it. When I actually access a variable, a string variable, the variable does not contain the word title. Instead, and let's just give this an address of 1001, the variable string actually holds 1001 because it holds the reference to the address. Now, there are other kind of reference variables. It's not just strings. It's just strings happen to be the easiest to deal with. When I talk about a scanner, okay, the scanner variable here is not like a primitive data, right? It's not like a letter or a number. It's something totally different, okay? So how do I store it in memory? I store it in the workspace. And I have a reference to it. So in memory, I have a memory called scan, and this is my scanner class. This is all the code for the class. Okay, and let's just say this is at 2001 is where that starts. Okay, so when I actually look at the word scan in my program, it points me to 2001. Okay, and then all this other stuff goes on over here in the way. So each variable name is associated with one address, one bucket, the same way you were taught in 168, okay? It's just that those buckets don't always contain the values of the variable. They can contain addresses that point to where the variable is actually stored. Okay, now, usually we're going to use a new operator to create a new instance of the object, okay? And that's called instantiation. Now, I don't have to use the word new with the string object. It is the only class that I can instantiate without using the word new, which I'm 6 one half dozen the other as to whether that's a good idea or not. All right, but that's the way it is. All right. Every time I use the word new, I call the string constructor. So what is a constructor? Every object, when they are created, you can have a constructor. The constructor will automatically run each time you create that object. Now you'd see this a little clearer, I think, when we create our own objects and you can see what we're doing with it. But at the moment, what you need to know is that there is a constructor there. And it runs every time you create the object. All right. We know that they have methods, right? So we can do title.length. We did scan. Mind has totally gone blank. How do we use the scan class? Do we have a dot prompt on there? Scan dot next line. That was it. Okay, thank you. I was trying to say read, and I knew that wasn't right. Scan dot next or scan dot next line. Yeah. Okay. Now, what this is, these are the methods. All right. These are the methods that are in this class. If it returns a value, if a method returns a value, it is called a function. So scan.next is a function because I can write name in equals scan.next, right? So this method here returns the value that is put in from the screen, all right? If it does not return a value, then it's simply called value, then it's simply called a method. Okay. Now, okay, back up here. Let me go back. Okay, come on, hang on. All right. The way that objects work is by the program asking the object to do something. I want you to think about this. You have a dishwasher at home, right? When you want it to wash dishes, you push the buttons or run the dial or however yours is set up, whatever user interface yours has. So in effect, you are asking the dishwasher to do something, correct? So when you hit that run button, you're telling it to go ahead and run. All right, this is the same thing. This scan object is communicating with your program. And by saying scan.next, you're saying, okay, go out here, see what next means, and then give me the value back that you get. This is what I was talking about when I said primitive variables. Primitive variables is the value itself, and that's this one, right? References are an pointer to the location of the object. Right? When we talk about references, a reference variable, very often we just do it like this. And the reason you do that so you're not making up addresses and people start thinking those are valid addresses. When we have an assignment, okay, and I'm working with a primitive variable, here's number 1, here's number 2. I do number 2 equals number 1. So this is currently has 96, this currently has 38, right? Afterwards, number 2 has 38, number 1 has 38. Simple assignment statement. It's the same way it's always worked, right? Empty bucket on the left, full bucket on the right. Okay. So, when I'm looking at references, it's different. here I have two variables, two different values, name 1, name 2, right? So I put in name 1 equals name 2. Name 1 still points to Steve Jobs, and guess what? Name 2 points to Steve Jobs. The value stored, actually stored, does not change. So if, let's just say this had an address of 1001 and this had an address of 1002. Afterwards, this would have an address of 1001, and so would this one, because they're both pointing to the same space where the data is stored. Questions? Does this make sense? Or are we so lost we have no idea? Okay? We're all right. Okay. Now, two or more references that refer to the same object are called aliases. We don't usually do this. Matter of fact, I would go so far as to say, in this class, we're not going to do it because of this. When you change an object through one reference, it's changed for all of its aliases. And that's really hard to keep track of. It's hard for me to keep track of. You're just learning how to program. We don't want to add that complication in there. Okay. Now, obviously, let's go back here a minute. One more time. Okay. Let's say I'm done with all of this. All right. I'm done with name 1. I'm done with name 2. I'm done with Jobs. I'm done with Wozniak. All right. How do I clear up that memory? Well, I clear up the memory through garbage collection. When the object is no longer referenced, it can't be accessed by the programmer. That's the other thing you have to be careful of, because you can accidentally wipe out a reference to an object, and if you do, it's gone. I mean, you can't get it. All right. The object is no longer available, so it's called garbage. Java performs automatic garbage collection. It's pretty good. It's much better than VB. VB's garbage collection tends to be wait too long. Of course, it's dealing with a lot more objects than most Java programs are either. Okay. All right, creating objects. Does anybody have any questions? An object is what type of a variable? Reference variable. All right. Reference variable means what? It's stored in a space in memory, and the variable name simply references the address of that space. Okay. That's critical, because when you start looking at how you think about variables, and you're thinking in your mind, okay, this is stored here, and this is stored here, and this is stored here, and this is stored here. Well, wait a minute, what am I doing with this thing? What does scan store? Well, what scan stores, because it's an object, it's an instance of an object, it stores an address to the rest of the method. All right. So the string class. This becomes applicable, especially when we talk about strings. Now, strings are a very powerful object, but they're also relatively simple to access, which is why we use them as the first object we're going to talk about. Now, as I said, we don't need to use the new operator in here. This works right there, but it only works for string. So one of the things in Java, which we talked about early on, was that each string literal is enclosed in double quotes. That is what a string object is. So the string object is actually this. Everything in those quotes. Okay? The title is the variable name. So the title is going to do what? What's going to be, if I go to title in memory, what is going to be stored? It's going to be stored a reference to an address, right? Okay. Now, the string is immutable. So if I do this, if I say name equals Joe, and then I say name equals Pete, over here in my space where I'm working on these things, okay, I have Joe stored, and this points to Joe, right? Now, Joe does not change to Pete. Immutable means it cannot change. Its value can't change, its length can't change, okay? So when I do this, what happens is I get Pete at a whole new address, and it goes here. Strings don't change. And if I went further and I went this, name equals Peter, when I did that, Peter would be stored in its own reference, and that would point to that. Okay? These two pointers don't go anywhere anymore because they've been replaced by this one. Now, one of the things we can do with a string is that we can get to a particular character. Remember I said in Fortran that the string was handled as an array, correct? It helps if you think of it that way. Meaning, okay, index is a 0, so the string HELLO, the character H is 0 and O is 4. 0, 1, 2, 3, 4. Now it's not an array, okay, but I can specify a numeric index and I can do it. Okay, so if we look at this, all right, change is inevitable. This is the phrase. So phrase, I didn't do that. Oh, I can't spell this morning. Phrase is our original string object. How many other string objects do I have? 4, because I've declared them all, right? All right. Now, in this one, I'm using the concat method. What do you think concat does? It concatenates, right? So change is inevitable, comma, except from a vending machine. That's what's going to be output right here, right? Because it concatenates. Okay? So that's one method. Concaten. Well, anyway. I have an extra I in there, but that's okay. Okay. All right, so that's one method. Now the second method says to uppercase. What do you think to uppercase does? It makes it all uppercase, okay? So uppercase is another method, and that simply, as we know, just capitalizes everything. Okay. Now, I also have a replace. What replace does is it's going to take every E and make it an X, so that this becomes an X, and this becomes an X, and this becomes an X. Okay? Does that make sense? All right. 4 says I'm going to find a substring. Now, a substring is a particular type of method which says that it's going to start at position 3, 0, 1, 2, 0, 1, 2, 3, and it's going to go for 30. And I'm not counting out what 30 is. We'll see when we get the answer. Okay? That it's going to return 30 characters. Start at 3, return 30. Okay? All right. So then we're going to print them out. Okay, so here is our length of string is 20. Change is inevitable. Here's the first one. Change is inevitable except for the vending machines. Okay? Here's the second one. Change is inevitable except for the vending machines. But notice that number 1, it still is concatenated. Okay? And number 2, it is capitalized. Now, if we go back, come on, there we go. All right. That's because instead of going back to the original phrase, mutation 1 was the long concatenated. Mutation 2 uses mutation 1. Mutation 3 uses mutation 2. Okay? All right. Change, whatever this is, and you have all the x's, e's replaced with x's, and then we're only going to get 3, 0, 1, 2, 3, so there's our n, okay, and we get 30 down, that would be down to the f. Now, our mutated length is only 27. Why? 30 minus 3. Okay, started on the third character and gave us 30. I'm sorry, it went to the 30th character. I said that wrong. So it started on the third character and went to the 30th character. Because notice that it gave us 27 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and spaces do count because what it counts are ASCII characters. Remember, even though we don't see anything where there is a space, there is still an ASCII character code for a space, right? So because there's an ASCII character code for a space, it counts. Okay. Questions? Does any of this make sense? Feedback, people. I don't read minds. Okay? We're going to look at some more examples of this, but okay. Now, what output is going to be produced by this? Okay, we're going to go around the room. Stephen, we're going to start with you. If I'm looking for the length method, what output is going to be produced? Or what am I going to do? Yeah, but it's a number of characters is what it is. It's a number of characters in that string. All right, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay? Does that make sense? String length gives us the number of characters in the string. Okay? All right, substring 7. Wait a minute. We're going. James, you're next. What does that mean? Substring sub 7. Okay, let's put a question mark there. All right, now if we go to, and what is the 7th character? 0, 1, 2, 3, 4, 5, 6, 7. It's a T, right? Okay, let's see. Then we're going to make, we know for sure we're going to have an uppercase T, and then we're going to look at the length. Okay? All right. So what happened? We started at T, right? And we got the rest, the final frontier. Okay? Now, we made the string go to uppercase, and then we did the string length. What is the difference here as opposed to this? Because this started off with 20 and our length here was 27. No, well, that's one of the differences, but there's another difference. Come on, Patrick. This one used the different mutations every single time, right? So this was the original phrase, then we had 1, then we had 2, then we had 3, correct? Okay. This one well, I guess it's not gonna animate over here. This one used the original phrase each time. Now, why did I point that out? Because you have to know what you're working with. Do you want to have just the characters you selected? Or do you want to have all the characters? Okay, so on the first one, we started at 3 and we returned 30. Okay? This one, we started at 7, and if you don't give it an ending argument, it's going to return to the end of the string. All right? But we didn't use that in the rest of these. All right, come on. Okay? So here, we started at 7 and we got the final frontier, but then right here, we go right back to the original one. You have to make sure you know what you want. And that other one would have been much plainer about what we wanted if it hadn't replaced all the E's with X's. Yes. Okay, hang on. Let me go back here. It's being difficult. Okay. C is a 0. 0. 1, 2, 3. Okay? Yeah, you gotta always start with 0. And that, you know, that's just one of those things you have to get used to. Raptor is 1 based. And I understand that. Every other language it works with 0 based arrays, 0 based strings. Everything else is 0 based. So you always have to figure, okay, the length. Okay, what is the difference between the number of characters in the highest index? The number of characters and the highest index. Okay, so in other words, this started off with 0, right? Okay, so 0, 1, 2, 3. All right, well, let's get it to a shorter one. Let me do this. Okay, so I have okay. What is the largest index of hi there? If I wanted to return this E, what would the index be? 0, 0, 1, 2, 3, 4, 5, 6, 7. Okay. What is the length? Because what does the length do? It counts the characters, okay? So when we talk about length, we're looking at 1, 2, 3, 4, 5, 6, 7, 8. I left off the, hang on. We want this to be right. 1, 2, 3 is the space. 4, 5, 6, 7, 8. And the indexes are 0, 1, 2, 3, 4, 5, 6, 7. So you're always one off. All right. Why is that important? Well, if you want to do something for all of the characters in there, okay, you cannot say a for statement, okay, for INTI equals 0 to length. If you do 0 to length, you're going to end up with an invalid index. Why? Because length is 8. Index ends at 7. So when you're working with this, it's always, if you're working with the indexes, it's always going to be length minus 1. Always. And that doesn't matter what language you're working with. I'm looking at PHP and Ajax, okay? And it's the same type of thing. So you have to remember that, because that gets you screwed up, because then you get an invalid index and you say, no, it's not wrong, there's 8 characters there. Well, yeah, there is, but there's not an 8th index. Okay. Any other questions? Okay, so let's look at, should have just done that. Okay, I gotta go back to that. No, that's not what I wanted. Okay, so let's look at this. Now that's Windows. Let's look at this one. Oh, that's not one. Okay, hang on a minute. No, don't say that. Okay, now this uses some of the things that we've just talked about. Anybody want to tell me why I have a typewriter right there? I have no idea. Okay, anyway, this uses some of the things that we've just talked about. All right, in the first place, it imports the scanner, right? There we go. It imports the scanner, correct? Okay. Then it creates a new instance of the scanner called scan. Now, it also uses random. Now, we're going to use random. We're going to talk about random here in just a minute. But what the random class does is create a random number. All right? So we're going to scan the first line. We're going to scan the second line. All right? So then what we're going to do is we're going to pick up. You see, can somebody tell me what this line does? You should know. You should be able to figure it out. Character at 0, right? So if I had Pete, then the P would be my character at 0, correct? All right. Then it says last dot substring. All right. Okay. Last is the last name, right? So it's going to start with 0. Okay, so if I have Smith, well, let's say Smithson, okay, then it's going to take 0, 1, actually it's going to take, starting at position 0, 1, 2, 3, 4, 5. So it's going to be P. Smith, okay, and then it's going to use the random number generator. We're going to go over that in just a minute. All right, so that's what we should have, right? Ah! Don't do that to me. Yeah, that's annoying when it does that. Okay. All right. So when we run it, we're going to do Pete Smithson. P. Smith, and then the random number generated 51. Okay? Does that make sense to everybody? So we use this. Yeah, we know that. Oh, well, that's because I put that there. There we go. We use this string methods to generate a username. You can use it to generate passwords. You can use it to generate all kinds of things. Right? One of the ways you can generate passwords is you have random words. And then you go in and you pick random letters from random words and random numbers. You generate a random number or two while you're in there. Some places have simply the alphabet with the whatever characters are allowed. So if you're allowed a slash and a hyphen and a whatever, all right? And it will simply go in and pick random things. Yeah. Okay. All right. Where are we at here? All right, let's go back to here. Yes, sir. Hang on just one moment. Okay. 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 So we are going to use a name and password on this.
Well, yeah, all the usernames are root.
Okay. Okay. Okay.
All the students choose password.
Okay. So in other words, they're going to go to here. All right. They're going to type in this address.
Yeah.
Okay. And then they're going to type
That's
in
just the home page. And then there's I believe on the home page there's a link to web shell.
Okay, so they need to go to web shell to do what they need to do. Or webmin.
I'm not sure. I've never actually used these for anything.
Okay, I'll work on it. I have a nice long lecture for tonight, so if I get stuck with this, I won't have to worry about the lecture. Okay, so.
And they're all static sets, so they'll stay.
Okay, all right. Okay, you're not leaving till 1.
Yeah, I might be asleep in the corner right now.
Okay. Okay, so we've used the string class to generate a username. All right, so now let's talk about the math and the other classes. All right. Well, that was not what I wanted to do. Okay, well, hang on here a minute. It just did something I didn't think it was going to do. Okay. The class library. Class library is a collection of classes. Now, when we talk about classes as reusable objects, we think in terms of Java or Visual Basic or something like that. But actual companies have their own classes, reusable library classes that they use all the time, because one of the things about objects is it saves time when you're programming. If you already have an object that has been debugged and you know works, why wouldn't you use it, say, to access the database, to connect to the database, rather than rewrite your connection stuff every time? You wouldn't. You'd use this object. So when you talk about a class library, yes, we're talking about the Java class library, but also about what might be available at a job. The standard class library is available with any environment. Various classes are part of the standard class library. Now, notice, even though they're part of the standard class library, that does not mean we don't have to import it, because it doesn't drag the entire standard class library into every program. Again, it's only going to import what you need. The class library is often referred to as an API, or Application Programming Interface. There are also specific interfaces. Now, Swing enables us to create forms and interactive programs. That's that one. The database API enables us to connect to databases and work with databases. What these are is this is a collection of related classes. If we were working in Microsoft, these would be namespaces. That's a dirty word in the Java language because Java is not Microsoft, but that's where you're going with that. All right. Now, if you go to this, oh, come on. Where's my magnet? Ah, shoot, it's not on this one. All right, never mind. All right, this address. Then you can get a list of all of the Java objects. There's a whole lot. Just let me say this. And there's no reason for you to, it's not that I don't want you to go look stuff up. Feel free to go look stuff up, but don't confuse yourself while you're looking it up. Because you will see you have string, and then you have string buffer, buffer input builder, characterization, content holder, index out of bounds, monitor, monitor mbean, name helper, reader, reference address, selection, sequence helper, sequence helper, sequence holder, string tokenizer, and that's just what I can read on the screen, right? You don't need to worry about anything until you need it. Now, what you can do is when you need to do something, is go and find something that looks right and then read your description. The Java API also varies. Well, this one doesn't because this is Oracle. Sun created Java, Oracle bought Sun. Okay, so that's why this is at Oracle right here. Now, packages, classes are organized into packages, okay? So our Java language is a generic support one. Our applet creates applets for the web. AWT and Swing are the two you use to create forms and stuff like that. .NET is network capabilities. Okay, don't confuse that with the Microsoft .NET platform. Just don't, all right? Utilities are utilities, and then you have XML parsers. Not even going to get into XML, but we do cover that in our web design. XML is a way of transferring data where the data maintains its context. So in other words, if I had a database, and in that database I had stored names, address, and phone numbers, right? And I had 30 records. If I transformed that into an XML document, I would still be able to tell which ones were names, which ones were addresses, and which ones were phone numbers. If I transform it into a text document, or a CSV, comma separated value document, I just get a list of stuff. I don't know which one is what, all right? XML allows us to maintain the context. And so then, if you have the context, then you have to break it out again. And that's what the parser does. And that's as much as we're going to say about that in this class. Okay. Now, we use, when we went to use the scanner class, instead of doing the import, we could have said java.util.scanner scan equals java.util.scanner system.in. Okay? And every time you wanted to use the scan, you would have to say java.util, etc. Okay? Obviously, putting it once at the beginning is a much easier way to do things, right? Let's face it. Okay. Now, you can also import all of the information in a package. Now, the utility package, you probably don't want to do that with because it's huge. When you're using the AWT, which is one of the graphics packages, most of the time what you're using is you're going to be using a large number of those methods, so you just go ahead and import the asterisk. And that's something you become familiar with as you use Java more. This class right here, java.lang, is your basic Java package. This is what Java started out with. And this is all you had until you got all these other things, okay? So you don't have to do this because Java says, I know you have to have this or you can't do anything in Java. So I'm just going to automatically put that in there. Without the java.lang package, you can do nothing. And that's why we don't have to import the string. We don't have to import the system, anything like that, okay? Because they are part of the java.lang class. If you want to know what's in all the classes, that's back in that documentation I just showed you. That's what tells you what classes are in each package. Now the random class generates random numbers. And yes, you can use it to generate lottery numbers. And if you win, good luck, you've earned it, because I've done it for years and I've never, I don't play the lottery, but I have generated the numbers just out of curiosity. I don't know that I've ever gotten more than 2 numbers. So, you know, that's the way it is. Okay, now, one of the things about the random object, it does complications. You don't need to know what those complicated calculations are, and that's the other reason for using objects. I don't care how it does it. I don't care how the scanner class gets the information from the screen. I just care that it goes off and does it. So I can use somebody's object to do something that I don't have a clue how to do, but that's okay. I don't need to know how to do it. I'm going to show you another example of that here in a minute. With the random object, you have a seed value. All right, that seed value produces the random numbers. Now, here is our, if I simply have an integer and a float, okay, and if I simply do this, I can have any random number. All right, now, I can have a random number from 0 to 9. Okay, if I don't have num1 as an integer, all right, this would come out as a decimal number. Okay, so I can generate, and this is our instance of our random class. Notice we have the word new. That means every time when we've done that, we've created the constructor, which enables us to use it. Okay. So now I can use from 1 to 10, okay, from 20 to 34, because of what I'm doing here. I'm using the generator, all right, from negative 10 to 9. Now, when I do the float, okay, I get a number between 0 and 1. So this is why I said back here, your basic random generator creates a number between 0 and 1. 0.12345, for example, okay? If we want to make it more specific, that's when we start giving it and telling it what we want. We want it to go from 0 to 9. So if we want to go from 1 to 10, okay, or actually from 0 to 10, we would put an 11 there. And here, with our floating, it goes from 0.0 to 5.999999. So I'm gonna have you enter these things so we can get this. But the numbers, the thing you have to understand about random generators, I had one student one time, kept running it all the time because he couldn't ever come up with the same answer twice. It's not supposed to, okay? It's a random number that's supposed to be generated. It's not supposed to come up with the same answer twice. So if we have a random integer, there's our integer. And we can generate a 0 or a 1 or a 5. There's a 3, a 30, a -4. Here's actually what this would have been generated as. Okay? And then here is a 3. Okay. All right. So if I do this, what am I going to get for values? Okay, remember I did a 10 and I got values from 0 to 9. So what am I going to get here? I'm going to get 0 to 24, right? Okay. All right, I do a 6 plus 1. What am I going to get? 1. Is it to 6? Let's put a question mark there, okay? Now, if I do 100 plus 10, what am I going to get? 10 to 100. Okay, 50 to 100 is going to be what? From 50 to 100. 10 minus 5 is going to be what? Okay. Okay. All right. Okay. This one is right. We were wrong with this one because it's going to go from 10 to 109 because of the plus 10. This is going to go from 100 to 149. This is going to go from negative 5 to 4. Now, why negative 5 to 4? Negative 5, negative 4, negative 3, negative 2, negative 1, 0. 1, 2, 3, 4. Gives me 10 numbers, but it starts at negative 5. Okay? All right. Okay, let's see. 22 plus 12, it's going to start at 12, and it's going to go to 33. Right. Why? What's 22 plus 12? 33. Maybe 34, but we always stop one before, don't we? Because of what? 0. Okay? The easiest way to generate your random numbers, okay, is to remember that I'm going to start at 10, okay, and I'm going to return 100 numbers, and none of them are going to be greater than 10. Okay, I'm just going to, and I'm not going to return them in order. That's just the range I'm going to have them in. Okay, 0 to 12 is what? Okay, 13, because you're going to do 13 numbers, okay? 1 to 20. Now I can do next int plus 1. Okay. Why can't I do next int 21? Because it might return a 0, right? Okay. 15 to 20. I'm going to return 6 numbers starting at 15. And remember, the thing you have to remember with these, okay, it is not returning 15, 16, 17, 18, 19, 20, okay? It's returning a random number within that range. So you have 6 possible values there. And this is the shortest one, so let's just look at this one. I have 15, 16, 17, 18, 19, and 20. Okay, 1, 2, 3, 4, 5, 6 numbers, right? Okay, so when this runs, the first time it may return a 17. The next time it may return a 20. The next time it may return a 15. All this is saying is that I'm going to start at 15 and I'm going to select my numbers from 6. Okay? From the next 6 numbers. That's what that's saying. So if we go back to Come on. If we go back to this one, okay, it's going to start at 100. All right. And then it's going to return from the next 50 numbers a number. So it could return 125, it could return 134, it could return 101. It could return any number within that range. And the same thing here. It's going to start at -10 and return from the next 11 numbers. Well, -10, -9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So it will return from those digits is what it will return. Okay, now the math class is also part of the Java language package. It's not addition, subtraction, multiplication, division, mod, increment, and decrement. We just went over those, right? That's not it. It's things like, what is the square root? What is the exponent? What is the absolute value? And my personal favorite, trigonometric functions, okay, which we don't cover in this class. Why? Because I don't do trig. Real simple. Okay. These are static methods. Okay. You do not need to create an object. You don't need to create an instance. So in other words, I don't have to say COS1 equals new COS. Okay? I don't have to do that. That's not done. All right. What is done is you would have the value equals math.cosine of 90 or math.square root of delta. Okay. Static methods we'll get to at the very end of the semester, but math classes are static methods. Okay, so now I'm going to input something, right? All right, ABC, I'm going to take A times x to the squared plus bx plus c. That is the quadratic equation, right? Don't panic. We're not going to do too much math in here. Trust me. All right. I really, really, really don't want to have to deal with it. All right. So let's look here. Okay. So I enter the coefficient of x squared, which is 3. I enter the coefficient of x, which is 8. A cosine, which is 4, and then it solves the quadratic equation. All right. Why anybody would wish to do that on a computer program, I don't know, because I can make it do it in Excel with exactly 3 numbers. See, there's some things it's just not worth the aggravation doing. All right, but having said that, all right, we're going to look at another example where the math class is very useful. Oh. Okay. All right, now. No, I'm sorry. I didn't bring those up. I'm sorry. Okay, hang on. I have it over here. Nope, I have it in here. Okay. So we can, all right. Okay. No, that's not going to do it. All right, let me get back over. I'm in the wrong. I don't want it to be in tablet PC mode. Go away. How did I get it in tablet PC mode? Close, close, close. I don't even know what, the worst part about it is I don't even know what I hit to get it to do that. That's the worst part about that. Either that or Mr. Loose has been playing again, trying to drive me nuts. Okay. All right. So let's look at, which one was I looking at? Let's look at a distance calculation. All right. All right. Do you see this math.pow? POW is how you can raise things to a power. Here is your square root. All right. These are the functions that are contained in the math class that are so advantageous to us when we're using the math class. All right. And of course, if you're really into the math where you need to do the cosine and the sine and all those trig functions are also available to you from the math class. Okay, so now, what I want you to do, why are you hollering at me? Don't holler at me. Okay. Chapter 3. There has been an error reported. Okay. Don't you just love these error messages? Yeah, the don't go away, which is not the way you want to write programs. How's that sound? You know, one of the things you have to remember when you're writing a program, especially an interactive program for a user, whatever the user can do wrong, they will do wrong. But that means your error messages must be clear, and they cannot get like that where they don't go away unless you close the program. Cannot, all right? Or give it the gobbledygook you get from Microsoft sometimes. There was, what was the one? Yeah, error message number something, something, something. There was an error in this code. Yeah? You want to give me a clue what happened? Yeah, no, you can't do that. So anyway, what we're going to do, I'm going to have you, as soon as I find this stuff, hang on. Give me a minute. It's getting there. I have faith. All right. All right, and this isn't going to come up. Let me see your book a minute. Okay. Okay, on page, hang on, I gotta go back here. Okay, on page 120, you have a program, and that's that mutation program. And on page 127, there's your random number program. And we don't need to do the quadratic equation, right? No, we don't need to do that. Okay, so before the end of class, I want you to enter both of those, upload them to a Dropbox I'm going to put up there, and then if you finish with those two, you also have your My Programming Lab to work on. All right? Okay, I'll release you, and you have time.